In this video, I'm going to go over this example, example 2, where I'm covering topics 3 and 4. We're going to organize continuous data into tables and histograms. Now, the continuous data, if you recall, is the data that can have decimals, right? So can have decimals, or I should say will have decimals. Not can, it will have decimals. But we also use these same techniques even with discrete data. So note, we also use with discrete data when there's a lot of numbers. Or when there are a lot of numbers. So I'm talking about it specifically for continuous data here, but it can also be used for discrete data under certain circumstances. Basically, it's numbers, right? Okay, so what we do is we build from those numbers classes, bins, right? So remember that the class, recall, class is the bin, right? The bin that we're putting things into. So in those bins, we have lower values. That's the lowest value that's within the class. We have upper values, the highest value within the class. And upper values tend to be a little bit shady because they're always rounded, but technically they go to 0.99999, especially with continuous data. So it's a little bit icky because, for example, if I look at this class right here, the lower class limit is 40. No problem, 40. But this number, I wrote it as 49.9. Sometimes we'll just write it as 49. Sometimes we'll write 49.99999. It's all depending on context. So they round them based on the context, but they really have lots of decimal places on them if you just want to put them down. It's a question of how much you feel like writing into your own table, but they're always there in the background. It's always going out to 0.99999. Because the next class starts at 50. So basically 49 all the way up, 49 and a half, 49 3/4, 49.9999999 fits into this class. But once you hit 50, you're in the next class, right? That's the way that works. They can be whole numbers, right? So they can round them to 0.9 or 0.99. They can also use whole numbers. So I'll just make another note. Can also be whole numbers. They can round to 39, for example, or to 49, rather than bother with the decimals. So you have to watch out for those. You have to know in the back of your head that even if it rounds it, it's really going out to 0.9999999. All right, now the class width. A lot of people get the class width wrong, so you really want to highlight it, right? Class width is the difference in consecutive lower class limits. It's how wide the bar would be when you make the histogram, right? So that's where the width comes from. It's the width of a histogram bar, right? So when you think about your histograms, you know, doing things like this, this is the width, right? Okay, but it's the difference in consecutive lower class limits. You do not, it's not from the lower to the upper. That's not the width, because this upper is really 0.999999999 forever. So what you do is you take the difference in consecutive, one after the other. That's what consecutive means. First this one, then this one, then this one. So you take the difference in those consecutive lower class limits. So I'll actually do it right here since I'm going to jump ahead and show you this example. Well, actually, let me finish my definitions and then I'll go. Open-ended class is when you see something like we see on the first part right here, where it just says below 39.9 and it doesn't give you an end to that class, right? So the only other warning I want to give you is about class width. So I'm just going to make a warning. So warning. Some distributions, some tables, distributions, do not have a consistent class width. So they don't have a class width. A class width has to be consistent. It has to be the same throughout the whole table. Open-ended classes don't count, so they're no big deal. Right? So they don't have a class width, in other words. That happens. I will give you ones that do have a class width, generally, for the most part. I'll try to give you ones that do have a class width. It's consistent class width. It has to be a consistent value down the table. But there are times in real life that they do not have a consistent class width, so therefore they don't have a class width. The class width has to be this consistent value through the whole table. It happens, I've seen it sometimes with age data in particular, because they'll put like, you know, for example, for driving, 16 to 18-year-olds, then 18 to 21, and then they'll do like 22 to 25, and then from then on they'll be, you know, 25 to 35, 35 to 45, 45 to 50, and it's consistent after that point, but it's not consistent for the beginning classes. That sometimes happens. All right, so the following frequency distribution shows the actual grade percentages on the final exam for 7 sections of Math 133, in case you're interested. This was from 2018, so this is a while ago. All right, so let's look at classes. So I said the classes are the bins. So this is the first bin, right? It's this row right here, and that's its frequency. This is the second bin, and that's its frequency. This is the third bin, and that's its frequency. So if you're looking for the third class, this is the first class right here. I'll just put it right here. First class is that one. This is the second class, and so on. So the third class, they're in order, right? It's called ordinal numbers, first, second, third. So the third class is 50 to 59.9. And again, some tables will just say 59. Some tables will say 59.999. It depends on the data that you have. All right, now what was the second class's lower class limit? So you go to the second class. The lower class limit is the lowest number that's in that class, which is 40. So that's 40. All right, now what about the sixth class's upper class limit? All right, so this is the third class, fourth class, fifth class, sixth class. So the sixth class is right here. So it's 89.99999, right? They wrote it as 89.9, but we could say 89.99999. And the way to do that is to put a little bar over his head, right? Because it's really going on forever. All right, now the class width, I was just talking about it, so let me get to it. What I was saying, it's the difference in the lower class limits. You can't count the first class. He's not involved. But you look at these other classes, 40 to 50, 50 to 60, 60 to 70, 70 to 80. They're going up by 10 every time. So the class width is 50 take away 40. It's 10. But you can also see it as 60 take away 50, or 70 take away 60, or 80 take away 70. They're the same. It's consistent. Right? It's always 10. Right? This is 10, and this is 10, and this is 10. Therefore, the class width is 10. All right, now the modal class. Mode is a definition we'll actually learn in chapter 3. So let me just write it right here. It's really easy though. It's the most frequent. That's what mode means. It's the thing with the highest frequency. So the modal class is the class with the highest frequency. So I look at my frequency numbers. 45 is my highest frequency. So therefore my modal class is 80 to 89.9. Just going to box that. And if you want to write a note, it's because 45 is the highest frequency. It's not 45 though. 45 is why that's the modal class, but the class itself are these values over on the left. They're the bins. All right, now let's get into a little bit of chapter 5 actually. So we want to pass this final exam. A student needed to score 70% or higher. What percent of students passed the exam? Oh, percentage question. Okay. Well, I know how many passed the exam because this is 70 to 79.9, 80 to 89.9, and above 90. So all three of these groups passed. So let me make a little note there. These three groups, all of them passed. So the number that passed, which is not the same thing as what they're asking, but the number that passed would be 32 plus 45 plus 34. Let me grab Desmos. That's what it's here for. And that's 111. Now, while I'm on the same subject, if I'm going to get a percent, I need to know the total. So I'm actually going to add up all the frequencies while I'm here. And I find that the total is 165. Okay, so I'm going to make a note of that. So right down here, I'm going to put a little sigma, which lets me know that this sum is 165. That's the total. And then I know that this is 111. All right, so then when I want the percentage, so this is number that passed, right? That's a number sign. It's also a hashtag, I know. But if I want the percent that passed, what I need is the number that passed divided by the total. That's going to give me a decimal. So that's 111 divided by 165, which is, I got to get out of here and into Desmos again. All right, so 111 over 165, it's 0.673, right? Because if we round that 2 up, we would go to 3. So 0.673. So 0.673. Now that's not a percentage. That is a relative frequency, if you will. It's a decimal. So the percent that passed is 67.3%. So it's a little bit of math. We had to add the big group and this little group. Then we had to divide, get a decimal, and change it into a percentage. All right, last but not least, why do we not know? Explain why we can't be sure if any student received 100%. We're actually not sure of any percentage. This just for the record. There's nothing special about 100%. There's actually two things going on. We don't know why anybody got anything, right? So let me answer this. Actually, I think what I'll do is I'll add a question. So explain why we can't be sure if any student received 100%. It's because the last class is open-ended. We don't know where it stops. I mean, we could take a good guess since this is an exam, it stops at 100%, but we don't know where the class ends. Open-ended means we just kind of say, yeah, above 90. Every number that's above 90 just goes into that class. Class ends. Okay, so that's one issue. But there is kind of another issue. We actually don't know what any student scored. And that's because the students are binned. For example, if I look at this class, 80 to 89, do you know what any of those 45 people scored? Do you know if they were 80 or 81 or 82? How many 83s were in there? We don't know. So actually, we don't know what any, and this is kind of a stronger answer, to be honest with you. So a stronger answer, I mean, yes, the last class is open-ended, but this is true no matter where we are. I could have said, here, I will say, I'll make this an H. Let me write this out. There, I'll add that in for future. So explain why we can't be sure if any student received 83%. And I just picked 83 out of a hat. It doesn't matter. And it's because the classes are binned, right? These are classes. These are, how about this? The grades are grouped. The grades are grouped into bins, aka classes. So we don't see the individual scores. So we do not see or do not know what any student scored. Right? It's grouped, right? That's another way to say that, right? They're grouped into these bins. So we don't know what anybody got, right? We just know what bins they fall into, but we don't know what any one particular student scored. And I'll give a note. That's the problem with grouped data, is that you don't know the individuals. Right? We don't get to know what any particular score was. We just know what bin it falls into. Which means, of course, it's open for manipulation. Somebody could play with those bin sizes and make the data appear differently. But that's a topic for another time.